Good morning, everyone. So yesterday we were discussing about OSPF. So in OSPF, first thing, what is the AD value of OSPF? AD value is 110. Then what is the protocol number of OSPF? 89. Okay. Then next we discuss that this is a link state protocol, right? Where link is what? Interface or connection point, and a state is what? How it is behaving, how it is connected. Then we discussed in the OSPF that how many states we have.
7.
What are those states? Down state, then init state, two-way state, start, exchange, loading, and at last we have is full state. In which state DR and bit election will take place, and where the master and slave election will take place. Next, how many packets we have?
5.
What are those packet types? Hello packet, DVD packet, then link state request, link state update, and link state acknowledge. Correct? Okay. Next. Oh, when the router sends hello packet messages, what are the information it saves? Like router ID information, area ID, network mask, IP addresses, all this information, right? Next. Okay. After this, what we discussed? Router ID. What do you mean by the term router ID?
Identification of
What is the size of this? 32-bit. It is an identification number that is used to identify a router in the network, right? So what is the first method? Manual. Second method, automatic from where? Highest IP configured on the loopback. And if there is no any IP configured on the loopback, then highest IP configured on the physical interface will be the router ID. Correct? Then DR and VDR. What is DR and VDR? So, like, why do we have this DR and VDR concept? To control the LSA flooding, we have DR and VDR. So the router with the highest priority number is going to be what? And the second highest priority number, VDR. If priority number is same by default, that is 1, then what will happen? Router ID. Router with the highest router ID will be DR, and router with the second highest router ID will be the VDR. And at last, we were discussing about the area concept. So there we discussed that area 0 is called as what? Backbone area. So the router having its interfaces in area 0 and in any other area, then we call it as what? ABR router. ABR router. Area number router. If it has one interface in area 0 and other interface in any other area, then it is called as a ABR. Right? Now, for example, let's say there is a one router. It has one interface in area 0, one interface in area 1, other interface in area 2, one more interface in area 3. Now, can we call it as a ABR? Yes, we can call. It is also a ABR only, but with multi-area. Okay, it is also called as ABR. Fine. Then at last, one more topic, ASBR, that is Autonomous System Border Router. Means that the router belonging to or in between two different protocols or in between two different AS numbers. So we call it as a ASBR, Autonomous System Boundary Router. Right now. Right. So today, before just starting the configuration part of the OSPF, we will discuss what is called as a wildcard mask. The wildcard mask is equal to global subnet mask minus actual submit mask. Or in a very simple term, you can say that this wildcard mask is reciprocal or opposite of submit mask, right? Now, see, for example, let's say I have given you that actual submit mask, in short, I'm calling it as a ACM, is slash 24, actual submit mask. So what is the value? 255, 255, 255 dot 0. Okay. Now we need to calculate WCM, that is wildcard mask. So formula says that you have to subtract this actual submit mask from where? Global. So global submit mask value is what? 255 dot 255 dot 255 dot 255. This is a global value, all 255. Then minus 255 dot 255 dot 255 dot 0. You will get the answer as 0 dot 0 dot 0 dot 255. So for this slash 24 submit mask, this is the format where we write the wildcard mask. Same process for each and every submit mask. Now, what is the requirement for this? Though we are using wildcard submit mask, so then what is the requirement of this wildcard mask? The reason, first thing that here it says that in this case, in the submit mask, that these are the network parts and 0 is the host part. Whereas in this, it says that this many bits needs to be matched, other it is not required to be matched, like that. Or we can say that, see, one more thing, that all the subnet mask is belonging to a particular classes. But this in wildcard mask is independent of the classes. It is not dependent upon that, right? So here it says that all the one bit means what? Network part, and it is what? Host part. Whereas in this, what it says that if it is having, like, it should match, which, what should be matched in here? Let's say, okay, let me give you one more example, then it will be clear. If I write here wildcard mask is equal to, or if I give you actual subnet mask, mm, slash 25 or slash 26 will take. So what is the value we'll get? 255 dot 255 dot 255 dot 192, right? Now, when will you calculate the wildcard mask? We will calculate like this: 1255 dot 255 dot 255 dot 255 minus 255 dot 255 dot 255 dot 192. What is the value we'll get? 0 dot 0 dot 0 dot 63, no?
Yes.
63,
Yes.
right? Even if you write any actual submit mask, sorry, it is ASM, no? If we write actual submit mask as of any other classes, irrespective of this one, that is called as a C. Let's take it from B. 18 we have taken, right? Now, what is the value we are getting here? 255 dot 255, 8 plus 816 plus 192 dot 0. Correct, no? Now, if we calculate, what we will get? 255, 255, 255, 255 minus 255 dot 255 dot 192 dot 0. What is the value we will get? 0 dot, then 63 dot 25. Right? So just what we are doing here, we are having any subnet mask, we are just subtracting it from the global subnet mask, and we are getting these values. Okay. So first, what you do, you calculate some of the wildcard mask, then we'll write all the properties of this wildcard mask. So you calculate for slash 25, then slash 30, then slash 10, and 16 or 28, you can write. Solve this four. Try to find the wildcard mask for all these four. Then we'll write all the properties of this wildcard mask. Do it fast, because after this, when we'll start configuring the OSPF, we need to write this wildcard mask.
Vishal, you're not audible.
Yeah. Just I'm writing, that's why. Which part can be?
Uh,
No.
I thought I'm not able to hear you. You're saying
Uh-huh.
something.
Which part can be ignored or can see? One more thing we can write. It is also applicable in ACL access control list, which defines the permit and denied traffic. So that's why it gives bitwise flexibility. Let's see. Done, written, solved. Got the answer. So you want me to solve or not? Not required. Okay, so these are the properties we are writing here. So it provides more flexibility irrespective of the classes. So here it says that 0 bits should be a match and 1 bits can be ignored. This gives a control access to like define which part, which network, or we can say which network is reachable. Like this, we can try. And here you are saying here this one, mid write in separate line, that it is also applicable in the ACL, access control list, which defines the permit and deny traffic based on this matching of the host part, and it gives bitwise flexibility. So like for example, if you are having 192.168.1.02, 192.168.1.100. Okay. So among this certain IP you need to not allow, deny. You want to deny certain IP, let's say from 1.90 to 1.99. Okay. So for that part, we can use this particular wildcard mask where whenever we are writing a submit mask, it is going to be opposite of that. Okay. So instead of writing all this 1.0, and then you will write like when you will write denying part, you write what? 192.168 1.0 till 192.168.1 dot, then 90, okay, or 89. Fine. After that, what will you write? 192.168.1.100. Only one. Because this is allowed, no? Between them, what we have done, we want to deny this part. Okay. So this is the one method we can write, or we can go with 192.168 dot 1 to 1.90 to 192.168 dot 1.99, and then we'll write the wildcard mask. So when will you use access control list? So you always write what? WCM, not the wildcard mask. Sorry, not the submit mask. Same is the case of the routing also. That gives you more precise control which traffic should be allowed, which part should be denied. That's why here it is saying you that 0 bit should be matching and 1 bits can be ignored. Whereas in the case of submit mask, what it says that 1 bit defines what? Network part, and 0 bits define what? Host part. Fine. So even just you are able to explain these all the things that it is going to provide you, or it supports. One more point you can add, that it supports variable length subnet mask. Okay. So if any question come, so you can write that this is opposite of what? Subnet mask, first thing. Then further you can tell or explain that, okay, that this gives more flexibility because it is irrespective of the classes, not dependent upon the classes. That's why. Then it supports what? Variable and separate mask. And in this, what you can write that it is in this, it is the rule says that 0 bit should be matching and other bit can be ignored. Okay. But even if you are knowing how to calculate this, it is fine. Right? So now what will you do? Like whenever we will take the routers, so in the OSPF for configuration purpose, first thing you will write here is router OSPF. Okay, this is a command. After writing router OSPF, you have to write one number, one value. And that value is what?
Yes.
Process ID. Right. In the EAGRP, here we used to write what?
Yes.
AS number. In the RIP, nothing is required. Whereas in the OSPF, we need to write here what? Process ID. Okay, what is this process ID? We'll explain you. Next, after this, you will write. See, if you want to write manually router ID, then the command is router, then ID, then you will write here the value. Now you know that if you will not write it, what will happen? It is going to take it automatically. Then after that, you will write here network, then network address. After that, wildcard mask. Then you will write area and then area ID. This is a sequence. It means here it is mandatory to write what? Area ID, wildcard mask, network addresses, all this information. Okay, now what is the meaning of this process ID and why do we need this process ID? Understand? See what happens. Why do we need this process ID? See, what is it in here? It says that it is a 16-bit binary number that is having a range from 1 to 65,535. Okay, it means that this is a range of what? Process ID. It says that it is locally present. Locally present means what? It is not going to have any importance in forming the neighborship. Generally, why do we need this process ID? So we can understand here two, we can say administrative differences. Right. For example, let's consider that we have a router. On this router, you have 10 network. How many network you have? 10 network. So you need to define all this 10 network. You have one option that you will define router, then OSPF, then you will write a process ID 1. Under this one single process ID, you are defining all this 10 network, right? Now let's say what happened that one of the network was not working. So you need to go through this particular process ID and you need to check which network is not working, right? So if here it is 10 networks, so it is going to be very complicated. You need to find all the network individually, right? What if we have distributed it? Means what I will do that though I'm having 10 networks here with this single router, so I will advertise first 5 network in a process ID 1 and rest 5 network in a process ID 2. So what we are doing now, we are distributing it under a different process ID. So what is the benefit will be there when you are doing the troubleshooting. Means whenever there is any problem with any of the network, to identify that problem, we will be using this particular things. So here it is required multiple, if you have multiple different process ID, that will be easy to identify. Because let's say in one process ID, you have advertised only 5 network. So which one is easy to check 10 or 5? 5 only, no? Correct? So it means what it says that, see, this allows for separate configurations and database which can be useful in the complex network designs. So what it says, separate the configuration. Rather than advertising all the network into a single process ID, we can have or we can use the benefit of having multiple different process ID. And it is meaning, see, process ID helps administrators to distinguish between different OSPF processes on the same router, making management and troubleshooting easier. It means on a same router, I can run multiple different process ID. I'm not talking about other routers. Same router I'm talking. On the same router, I can run process ID as 1 also, then process ID as 2 also like that. And even if you have router 1, here you have advertise the network under the process ID as 1. Router 2, you have advertised here the network under the process ID 2. No problem, they will form the neighborship. It means they are not dependent upon process ID. Where it is having the importance? Vertically. Vertically means what? On a single router. See, when I am talking about horizontally, it means on multiple different routers. So it does not have importance on the horizontal way. It has importance in the vertical direction. Means on a single router, you can run multiple different process ID. And one more thing, each process ID requires unique router ID.
How do we give different unique IDs to same code?
Now only I will say you how will you give that. You got the basic idea, what is the use of process ID?
Vishal, can you please
Mhm.
explain once again about process ID, please? Why we need it exactly for?
Okay. See, it is written here, that the process ID helps administrator to distinguish the network or distinguish the between different OSPF processes on the same router, making the management and troubleshooting very easier. As I told you that if we have a router, with this router, maybe you have multiple different networks associated. You need to advertise this, correct? Now, when you are advertising this, so you will write a router, OSPF, and a network process ID as one. Okay, let's say, consider that this first five network is a part of any other department. Okay, maybe sales department. So you want to advertise all this network into one process ID so that when you are having any communication or whenever you are doing any troubleshooting, you are knowing that, okay, what I did that with this router, I was having three different network, and this is a part of one other organization or any other part or any other department. So that's why I have advertised in the single process ID, right? This is all my five network. On the same router, I have five more network. Now this I am advertising in different process ID. One, two, three, four, five. Okay. So what you did on the same router, you were having multiple network, but you have differentiated it, distributed it into the different process ID, so that whenever you are checking, whenever you are doing troubleshooting, it can be easy for you to identify at this part, this network, I have advertised in which process ID. Let's say, for example, you have advertised 192, 168, 1.0, and it is not working now. So you know that, okay, let's say I have advertised this in the process ID under one. So I am going to check under one only, not in the two, right? If you would have advertised all the network into the one only, so we will be having multiple different networks. So management become what? Little bit difficult. Okay, that's why what we are doing, we are distributing it on a single router with multiple different process ID. But as of now, under this CCNA level or CCNP level, it is not required. We will be having only single process ID, and we will be defining multiple different networks over there. It is required only when you have more networks, right? Clear till here?
So suppose we are accessing that failed network.
Hmm.
Should we like go in a sequence one by one, or can we directly access that?
See, like whenever you are accessing that, first you need to verify what all the things is not working, which network is not reachable. You have to verify that part. So whenever you are verifying that, you need to go not individually. You can go with that network as well, but for troubleshooting purpose, at least you have to land it to where? To that process ID. See, first you will go to that process ID, then only you will do the reconfiguration. Correct?
So we'll go to that process area and check all the networks and get
Right.
to know which is
Right.
good.
So troubleshooting becomes a little bit easier. See, for example, if you have taken a router here, let me configure one IP here. This is going to be 192.168.1.1/24. And this side will take one IP as 1.1.1.1/1. Okay. Two IPVs there. One is physical interface, one is loopback interface. Now come to this router, give no, enable, config space T, and host name is router 1, interface is G0/0, IP address is 192.168.1.1.255.255.255.0 and give no head, give exit, then interface loopback 1, IP address is 1.1.1.1.255.255.255.0 and give exit. That configure the IP. Now router OSPF. Now give a question mark. What it says? To write a process ID. So I will write a process ID, let's say 1. Okay. I will not define any router ID. Let's see what will happen. I will not define the router ID. Fine. And I will define one network here. Network is what? 192.168.1.0. 0.0.0.255. Why? Because it is /24. And what is the area? 0, let's consider. Done. Advertised. Now, to show IP OSPF. Never. To show IP. This is the problem with the Cisco packet tracer. So if I am giving here command, so IP OSPF, what it says? What is ID? 1.1.1. Why it is 1.1? From where it is taking? Loopback interface. So for the first time, it is going to take it from where? Loopback. Okay, fine. Next, again, you do config to come to config space T. Give your router OSPF, this time 2. Process ID, second I'm running. Network is 1.1.1.0. 0.0.0. Area is same. Done. Show IP OSPF. What is it then? Routing process OSPF 2. What is router ID? It means whatever I am telling you is correct. That I am telling you that each process ID will be having what? Unique router ID. It is correct also. I have not assigned. I have not assigned the router ID. Automatically it is taking. So it says that, okay, as you were running here OSPF 1, so we were having one unique router ID, that is 1.1, means IP was there, loopback IP. So I have taken this as a router ID for process OSPF process ID 1. Next, I was running this one, OSPF process ID is 2. So it took this one as a router ID because already loopback IP is in use. So what is left? IP on the physical interface. This has been taken as what? Router ID. Okay. Next, one more I will run. Come to config space T, router, OSPF 3. What it says?
Yeah,
Why?
there must be one, at least one IP address.
When I am giving the command router OSPF 3, what it says? OSPF process 3 cannot start. The reason? Because it says that there is no any other IP that I can use it as a router ID. That's why it is not possible for me to run the OSPF 3. Because I have given only 2 IP, 1.1 and 192.168.1.1. So both this IP has been used as a router ID. One is for OSPF process ID as 1, and one is for the OSPF process ID as 2. So same router, but for two different process ID, you have two different router IDs. That is going to be unique. But when we are starting this one, it says that I don't have any further IP that can be taken as a router ID. That's why it is not possible for me to start the OSPF 3. Correct? Now, if I give here router ID as 5.5.5.5, is it possible? Now give exit, again give exit. So IP, OSPF, yes, see, OSPF 3 with ID as 5.5.5.5.
But network not.
No problem. We can give any other random number. No, I told you. The first method is manually. Manually, I can give any number. Correct? I have given that. So if I have given, it is taking. Got the idea? Understood? That we can run multiple different process ID. And apart from that, even we can configure this router ID as well manually. Clear? Now you have to tell me, you have to do a research for that. And you will tell me how many process ID we can run on a single router. As of now, you are seeing this. So let's say I can keep on adding no OSPF 5, 6, 7, 8, and like that I will keep on adding a router ID as well. So you need to search about that. Fine. Understood this part?
Yes.
Okay. So what will you write here? Process ID is used to separate the configuration for better management of the network and easy for better management of the network and troubleshooting. Then what will you write? Each process ID requires unique router ID. And one more thing, one extra line you can write, that process ID do not play any role in neighborship. Okay, Swapna, it depends upon the types of the router that we have taken. Okay, I think I have discussed in the CCNP class, routing CCNP. And there we have discussed that it is going to be more than 10. So search again, then let me know. Okay, do not play any role in the neighborship. So let us take some routers here. So we'll take 1, 2, 3, 4, and 5 router we have taken, and one switch will take. So let us take it this way. Consider that this one is router 1. Router ID is 1.1.1.1. Okay. And IP will configure it on interface is 10.1.1.1/20. Okay. This is what router 2. Will configure one router ID here, that is 2.2.2.2. Then IP is what? 10.1.1.2/1. It means all the router is a part of what? Same network. Common subnet, correct? Then router 3, 3.3.3.3. IP is what? 10.1.1.3/24. Correct? Next is what? Router 4. 4.4.4.4. IP is what? 10.1.1.4/24. Then here is what? Router 5. 5.5.5.5. IP is what? 10.1.5/20. Done. Now we'll start the configurations. Come to first. Let me use a notepad only. So router 1, interface G0/0. IP is what? 10.1.1.1. 255.0. Done. Come to router second. Router third. Done. We have configured the IP addresses on all the routers. Now come to this router. Start configuring here OSPF. So what will give? Router OSPF. So you can consider here that all this router is a part of single common process ID and with also a single area, let's say area 0. So all this router belong to which area? Area as 0, and process ID will take it as a same 1. Now come to this router. So router, then OSPF, process ID is what? 1. Next, when you will give a question mark, router ID, yeah, it is telling you to add here what? Router ID. So router ID will add. Now, when you will give a question mark, what it says? That it should be in what format? A dot, B dot, C dot, D format. Let's say here I'm giving here what? 1 dot, 1 dot, 1 dot, 1. Next, network we have to write. Now, all this router is a part of common network, that is 10 dot, 1 dot, 1 dot 0 network I am writing. Network address. What is that? 10 dot, 1 dot, 1 dot, 0. Then give a question mark. What it says? Wildcard bits we have to write. What is that? 0 dot, 0 dot, 0 dot, 255. Then again give a question mark. What it says? Area we have to write. Write down the area. Again give a question mark and see what is the range of the area. These many areas. Okay. Now, so to write the area, we have two format. Either we can write it like this one, number format, or we can go with this format also. A dot, B dot, C dot, D. But most preferred is decimal values. So we'll write here area directly 0. Numerical values. Right? Done. Only one network we have. Give, exit. Next, come to second router. Give here router OSPF 1. What is the router ID? 2.2.2.2. IP already has been configured. That's why. Router ID network is what? 10.1.1.0, 0.0.0. Area 0. Right? Give exit. Come to router third. Router OSPF 1. What is the router ID? 3.3.3.3. What is the network? 10.1.1.0, 0.0.0.255, and area is what? 0. Give accept. Come to router 4. Router OSPF 1. Router ID 4.4.4.4. Network 190.10.1.1.0, 0.0.0.255. Area is what? 0. Give exit. Come to router 5. Router OSPF 1. Router ID is what? 5.5.5.5. Network is what? 10.1.1.0, 0.0.0.255. And area is going to be what? 0. Done? Configured? Now see, when will you check now? Do show IP route. It is not going to show OSPF. The reason? Because all the routers are in this common separate. No, if they will be in a different network, then only routing is required. But why we have taken here? To see DR and BDR election. Okay. Do show IP OSPF. Give exit at first. Show IP OSPF neighbor. Show IP OSPF neighbor. What it says? What is this? PRI? These are the priority number on the router. By default, it is what? 1. That is correct. Now, it says here you that 2.2.2 is BDR. Let me check it from router 3 now. Give exit. Show IP OSPF neighbor. What it says? That 1.1.1 is DR. this information is correct or wrong? This information is correct or wrong? If correct, why? If wrong, why? Very simple question I'm asking. It is telling that router ID with 1.1.1 is DR. It is correct or wrong? If wrong, why it is wrong? Okay, router ID should be considered. Okay. So among this five router, fifth router is having the highest router ID, that is 5.5.5. And it should be what? DR router. But here it is not happening. So in the OSPF, one thing you have to do, clear IP OSPF process. It means for the first time, if we have configured router 1, so automatically router 1 is becoming the DR routers. Second time I have configured router 2, so it is becoming what? BDR routers. So we have to clear the IP OSPF process for having the election. What command will give? Clear IP OSPF process. Enter, give yes. Just give yes or why. Find this. So we need to do it on all the routers. Clear IP OSPF process, yes. Next, clear IP OSPF process, yes. At least we have to do it on the routers that has to become what? DR or BDR. And this command will work in the enable mode. That's why give here clear IP OSPF process, yes. On the fifth also, give exit, clear IP OSPF process, yes. Done. They've cleared that. Now you come to this router third, and this time again check show IP OSPF neighbor. Now what it says? Who is DR? 5.5.5 is the DR. And again, this one will become the BDR because it is 4.4.4, but it is not showing you now. Again, we have to clear that. So if we clear that process, it will become the BDR. Let me clear it here only. For till this one is a BDR only. Show IP OSPF neighbor. So it says that here this one is a TR. Okay, this one is a BDR. But again, we will clear the process. This has to become the BDR only. And this will only become the BDR. Okay, because of the second highest priority number. Router ID, right? So here what happened that the election has happened based on the router ID. It means that router ID can also be called as what? Neighbor ID. Okay. Router ID can also be called as what? Neighbor ID. And to check the neighboring information, what command we write? What command we use here? Show IP OSPF neighbor. Show IP OSPF neighbor command we use to check neighboring information and also DR and BDR info. So as of now, what happened that the priority number on all the routers were 1 by default. Now what we will do that we will change the priority number on all the routers, and then we will see how the election is happening here. Clear till here? Okay. So here what we will do that on the router 1, we'll give the priority number as what? 5. It means now I want to make this router 1 as what? Router ID. At present, who is router ID? Means who is DR? 5. Now I want to make this router 1 as what? DR. That's why. This one is what? BDR. So I will give you the second highest pattern number, that is 4. This one is what? 3. This one is 2. And by default, this is 1 only. So no need to change on this router. Now come to this router. Config space T. You gave interface number G0/0. To change pattern number, the command is IP OSPF priority. Give a question mark. This is a range of priority. 02 255. So I want to give it here what? 5. Then give exit. Come to router second. Config space T. Interface G0/0. IP OSPF. Priority is what? 4. Give exit. Now come to router 3. Come to config space T. Interface G0/0. IP OSPF. Priority is what? 3. Give exit. Next, come to this router 4. Config space T. Then interface G0/0. IP OSPF. Priority is what? 2. And even if we not change here, no problem. By default, it is 1 only, right? So again, you come to router third and check. Do show IP OSPF never. What it says? That still, if you will find here, see, these are the priority number that we have changed here. That for the router fifth, the priority is 1 only. For router 1, we have the priority is 5 that we have changed. Now, when will you observe still this one as a DR? Okay. So what is required here? Clear IP OSPF process. So come to router first. Give exit. Clear IP OSPF process. Yes, it means for re-election. For re-election, we have to clear this. Give exit. Clear IP OSPF process. Yes. Router with the least router ID. But highest priority number is what? DR.
Yeah.
And router with the second lowest neighbor ID or router ID or the second highest priority number is what? VDR. It means you got that always the election will happen based on the priority number. If it is same, then only it will go to check for what? Router ID or we call it as a neighbor ID. Clear it is?
If router 1 is having 4 high priority number and router 2 is having 4 and other 3 is having same, what the priority number?
If you are having the router 1 and 2, okay, let's jump to it. We have very exciting question. So let's, you want to keep rest router as the same priority number, right? Interface G0/0, IP OSPF priority as 1, give exit. Come to config space T, interface G0/0, IP OSPF priority as 1. Interface G0/0, IP OSPF priority is 1. Done. Give exit. Now again do the same thing. Clear. IP OSPF process, yes. Then again do it here also. Here. IP OSPF process, yes. You all have laptop? Yes. Take out. Here, IP OSPF process, yes. Come to router third. Show IP OSPF neighbor. Yeah, see. It's still the same thing, no? First, it will check for the what? Priority number. Whoever is going to have the highest priority number, that is going to become the DR, rest other is BDR. And whatever other is left, that is having the common priority number also, that will become the DR other routers.
What?
Huh?
You said 2 router cells is 5.
Then how the election will happen? Then again, in that scenario, it will take it router ID. See, same means what? You can keep it 1 on 1 also. You can keep 5 also, 2 also. Whenever it is same, irrespective of any other numbers, if it is same, it will always compare using router ID. Right? Clear? Yes. What about honest? It is clear? Clear now? Please confirm. Okay, so now write down. To change the priority number on the router in OSPF. Command is interface number, then IP OSPF priority, and that number that we have to write it, right? 02255 it is. Any number we can get, any number we can write it here. Next, by default, the priority number on the router is 1. Okay. If the priority number on the router is 0, then it means that this particular router will not participate in DR and BDR election. It means if priority number on the router is 0, then it is not going to participate in DR and BDR election. No, it is not participating. How it can be considered as a DR router? No. It will be DR other. Clear till here? Okay. See, DR and DR other. And will be in which state?
Full state.
DR and DR other will be in full state. Next, DR and BDR will be in which state?
Full.
Captain should have all the information regarding vice captain. Full state. Right? Same as BDR should have all the information regarding what? Other team
Yeah.
member. That is full state. And DR other and DR other will be in which state?
Two-way.
Two-way state. Yes. Now everyone take 2 routers, and if you want from online student, anyone can share your screen and start configuring on the Cisco packet tracer. I will guide you. I will guide everything. Let me know if you're okay with this. Anyone who wants to do that? Please confirm me fast. Yes or no? No one is willing to do that? I'm asking to Swapna and Arpita.
Not me.
Okay. So let me do it one thing.
Sorry, the emoji wrong clicked. Just trying to set on it.
Okay, so we'll take two router. You also take everyone. See, whatever I'm taking, do the same. Take two router. Done. I will check. Taken. No laptop. That's why I told you from tomorrow, everyone will bring their laptops, right? This is computer networking course you are doing, and we're not bringing your laptops only. How it will work. So now you give here 192.168.12.1. This side you give it 192.168.12.2/24. This side we will be having one IP as 1.1.1.1/24. Next 11.11.11.11 /24. Next is 2.2.2.2/24. 22.22.22.22/24. Don't talk. Written. Done. So for the router one, we have, you can consider that this is the router one. And this is what router two. Both this router is a part of common area. That is what? Area one, this side. This time area one it is. Come to this router, CLI. Interface G0/0. IP address is 192.168.12.1.255.255.255.0. Then no shut. Give exit. Doing the same thing, no? Then again interface. Okay, give it a host name also. Host name will be R1. Next interface, loopback one. IP address is 1.1.1 and 255.255.255.0 and give exit. Interface loopback to IP address 11.11.11.11.255.255.255.0. Give exit. Do show IP interface brief. We have configured all this IP. Next, come to this one, second router. Give here no enable config space T. What is the host name? Router 2. Interface is G0/0. IP address is 192.168.12.2 and 255.255.255.0. Give no shut and give exit. Then interface loopback 1. What is IP address? 2.2.2.2 255.255.255.0. Give exit. Then interface loopback 2. IP address is what? 22.255.255.255.0. Give exit. Done till here. Verify, do, show, IP, interface, brief. Now you can see here that from router 1, if you want to reach this network, routing is required. From router 2, you want to reach this network, routing is required. So we'll do here OSPF. So come to this first router and give the command router OSPF 1. This time, last time what we did, on all the routers, we gave the same process ID. This time I will give different process ID, not on the same router, but on different router, and I will show you no any problem will be there. Then also it will form the neighborship. So first command what we have given, router OSPF1. Next, this time I will not give the router ID. Let it take automatically. Okay. Network is what? Three different network we have. One is what? 192, 168, 1.0, 0, okay, 12.0 it is. 12.0, then 0.0.0.255. And what is the area? 1. Same common area. Again, one network. 1.1.1.0.0.0.255 and area 1. Even you can put it into area 0 also, then also it will form the neighborship because area 0 and area 1 can form. Because if you have two different area and one is area 0, then communication will happen, no? Backbone area connectivity. Network 11.11.11.0, 0.0.55, area 1. Then given the commands. Yes. Router OSPF. See, this side I am giving a process ID as a 2. Okay. Network is what? 192. One common network we will have to give, no? So 192, 168, 12.0 and 0.0.0.255. Area is 1. Next, network is 2.2.2.0, 0.0.0.255. Area is 1. One more network, 22.22.22.0, 0.0.0.255. Area is what? 1. Done. Now you come to router first and check IP routing. Give command exit and check show IP route. See what is written here? O stands for OSPF. Now here it is written 2.2.2./32. Why? Listen here, don't talk. Why it is written /32? Because the reason in OSPF we have one network type that is called as a loopback. And for the loopback interfaces, always it will consider it as a /32 because one loopback, one IP is it considers. That's why it will maintain as a /32 value. Okay. Now what is the AD value? 110. And this is the cost, metric cost, that is 2. Same as you can find it here also. OSPF. And this is the value. Okay. Now, when will you check show IP OSPF neighbor? Now see here that I am on which router? Router 1. Who is the neighbor for the router 1? Router 2 is the neighbor, right? So router 2 is the neighbor. So for him, it means a router ID for the router 2 is what? 22 dot. Why? Because if you will observe here, we have 3 different IP on the router 2. But the highest IP is this one. That too also where? loop back. That's why this is becoming the router ID for the router second. And from where we are checking this? From the router one, we are checking this. Same as you can check it from where? From the router second for the router one. What command will you give? Give exit, show, IP, OSPF, neighbor. What is it in? 11.11.11. Why? Here also, which one is the highest? This one is the highest. That's why this is being considered as what? Router ID. Now we will check DR and BD election. Now, among these two router, who is having the highest router ID? This one, no? So this one should be my DR. But who is showing you? It is showing you that this is my BDR. Wrong information. Again, clear the IP OSPF process. Clear IP OSPF process. Give yes. Do it here also. Clear IP OSPF process. Give yes. Now come to this one. Show IP OSPF. Show IP OSPF neighbor. See, this one is what? DR out. Understood this? And same as you can check it from here also. Show IP OSPF neighbor. And this one is what? BDR out. Clear? Understood? This completes OSPF. So whatever the configuration I have done, do it fast. So after the class, we'll go to lab, we'll access the real devices. Okay. Tomorrow we'll start with access control list, ACL. Okay. So all students. So we are done for the day. We'll stop the recording here.